Imagine you're a director, but your actor, your set designer, your cinematographer, they're all a single AI. Now, the promise of AI video has always been absolutely incredible, but it's always had this one massive challenge.
Right? How do you actually direct an AI? You can't just yell action and hope it figures it out. You've got to give it precise, layered, and sometimes even conflicting instructions.
For any creator, the absolute dream is to give the AI all of this at once. Hand it a photo for the actor's face, a full script for what they need to say, a motion guide for exactly how they should move, and a description for the entire scene.
But for pretty much every AI model out there, that is just way too many cooks in the kitchen. You try to process all that, and things just fall apart. The video quality tanks, instructions get ignored, the final result is basically unusable. Or at least that's how it used to be, until now.
So this brings us to the core problem that researchers at ByteDance and the Chinese University of Hong Kong wanted to solve. They call it the AI video dilemma. And it's this constant, frustrating trade-off between how much control you have and the quality of the final video.
And this really breaks down that trade-off perfectly. On one hand, you've got what are called reference-to-video models, or R2V. They are amazing at making your actor look just like a reference photo, but they can't handle audio. They're basically making silent movies. Then, on the other hand, you have audio-to-video models, or A2V. These are great at lip-syncing. The problem? You can't give them a detailed photo to base the character on. So you could get the look right or the sound right, but you could never get both, not with the kind of control you really want.
So these researchers were staring down three huge hurdles. First, that trade-off we just talked about. Every time you add another layer of control, like audio or a specific pose, the video quality just tends to nosedive. Second, what they call the data problem. I mean, think about it. Finding perfect training data that has the video, the text description, the reference images, the audio, and the pose data all neatly linked together, that stuff is incredibly rare. And finally, the measurement problem. How do you even prove your model is the best when there's no standard test for a task this complicated?
And that's where the hero of our story comes in. A brand new framework designed to solve this exact dilemma. Let's meet OmniShow. Now, OmniShow is built for a really specific but super practical task called Human Object Interaction Video Generation. Yeah, it's a mouthful, I know. HOIVG for short. But just think about e-commerce demos, or short-form video ads, or even interactive entertainment. It's all about making a person interact with an object in a totally believable way, all based on a bunch of different commands at once. And here's what makes it such a game changer. OmniShow has 4 separate control knobs that it can listen to all at the same time. You give it a text prompt for the scene, a reference image for the look, an audio file for the dialogue, and a pose sequence to control the movement. It's the first system of its kind that can actually harmonize all 4 of these things.
So how in the world did they pull this off? Well, it wasn't about just throwing more data at the problem. Nope. They had to invent some incredibly clever new techniques. Let's get into the secret sauce here.
It all comes down to this really elegant 3-part process. How they smartly inject all the visual info, how they get the audio perfectly synced up, and a pretty revolutionary way they approached training the model itself.
Okay, first up, injecting the visuals. Think of the AI's creative process like a flowing river. Now, instead of just dumping the reference photo and pose data in, which would be like dropping a huge boulder in and making a messy splash, OmniShow does something way more subtle. It uses a special technique to gently place what they call pseudo-frames. You can think of them like little paper boats of information into the current. This gently guides the final video without messing up the model's fundamental understanding of how things work.
Next, the audio. To get that perfect lip sync, the model has to know exactly which sound goes with which split second of video. So, OmniShow uses this technique that's kind of like putting blinders on the AI. It forces each frame of video to only pay attention to its matching tiny little snippet of audio. This stops it from getting distracted by anything else and creates that precise, frame-perfect sync that we see in real life. And this last step, it's just brilliant. Remember that data scarcity problem? Well, instead of trying to find one magical data set that had everything, they trained 2 separate specialist models. One was an expert in audio to video, and the other was an expert in reference to video. It's like training a world-class sprinter and a world-class long jumper separately. Then, once they were both amazing at their one thing, they merged them together into a single generalist model, basically creating a decathlete that could do it all.
Now, all of this sounds fantastic in theory, right? But the real question is, does it actually work? Because, let's be honest, claiming your model is the best is easy. Proving it, that's the hard part.
And remember that third big hurdle? There was no standardized test, no benchmark to even evaluate a model that could handle all 4 of these inputs. So, how could they possibly prove that OmniShow was actually the new state of the art?
Simple. You build a tougher test. The researchers actually created HOIVG-Bench, a brand new, comprehensive benchmark with 135 carefully curated samples, each one complete with text, reference images, audio, and pose data. It was designed from the ground up to push models like OmniShow to their absolute limit.
And honestly, the results kind of speak for themselves. Take a look here. On the left, you see a competitor's attempt. Notice how it really struggles with the composition? It almost looks like the object was just pasted onto the scene. Now look at OmniShow on the right. The person and the object are integrated perfectly. It just looks far more realistic.
Okay, now let's add audio into the mix. A super common problem with other models is this frozen body issue, where the lips are moving but the rest of the body is just weirdly stiff. But look at OmniShow. It generates these natural body movements that actually sync up with the speech, making the whole performance way more believable and dynamic.
And it's not just about what the computer thinks. When real people were asked to judge the results side by side, the preference was really clear. In these head-to-head showdowns, a clear majority of users preferred OmniShow, both for its overall video quality and for how accurately it followed the pose instructions.
So what does all this tech actually mean for creators? This is where it gets really fun, where the theory meets practice, because this unlocks a whole new kind of creative playground.
We're not just talking about a small improvement here. This is a leap into having new creative superpowers. You can create audio-driven avatars with just a single picture and a voice clip. You can do object swapping, like take an existing video and replace the product someone's holding with a completely new one. Or you can do this crazy video remixing, combining a person from one video, a pose from another, and an object from a third to generate something that has literally never existed before.
This all comes back to a really powerful insight from the researchers themselves. They said, and I'm quoting here, "We found that striking capabilities can emerge simply by merging R2V and A2V models. In other words, by smashing 2 specialists together, a new, more powerful generalist was born, one that had abilities neither of them had on their own. This idea that you can create new forms of control just by merging models, that's a seriously inspiring discovery."
So we've gone from struggling to give an AI even one clear instruction to now being able to give it 4 complex ones all at the same time. The role of the creator is really shifting, from just being a prompter to being a true director. So the question is no longer if an AI can follow our directions, it's what stories are we going to choose to tell?